Preventive measures for our creep failures. So what are the preventive measures that we could take so that we can avoid the creeping failure? Okay. So to mitigate the creep failures, engineers employ the several design strategies. First one is with high temperature alloys. So we are manufacturing the alloys, and the alloys must be having the very high temperatures. I mean, suppose you have the basic materials. Alloy is what? Combination of the two materials, right? So first material would be the they are having not temperature high temperature resistant, but the other material we can incorporating in them that are having high temperature resistance. So in overall and combined, their value would be in between them. Okay, so we can design the alloys, or better we can say the composites these days. Okay, they have they are being designed according to their application part so that we can resist the clipping. Though suppose we need to apply some material in some component, they must be experiencing suppose 500 Kelvin. So we must be designing the material which can resist the temperature till 600 or 700 Kelvin, so that we are not having a creep formation or creep phenomena inside the materials. For that, this is the way we can avoid the uh, you know mm, creep failure. Okay, so choose the material with the high melting point. Obvious high melting point means they can resist the temperature for a high temperatures. Melting point means what? If they would not be able to resist, then at the end they will be melting. Okay, so if they are having the high melting point, it means they can resist the temperature for a high temperatures. Grain boundary strengthening. We have seen that the grain boundary also play a role, for the creep. So what we can do use a large grain size or single crystal materials, because we have seen that smaller size or fine grain size is responsible for the creep. Okay, because due to the fine grain size, there is a diffusion. Okay, for that what we can do, either we can or grain boundary sliding over each other. So what we can do not having the fine grain size, but the larger grain size and of single crystal. If there will be the different crystal, different grain size, then there must be the grain boundary. If there is grain boundary, then grain boundary sliding will occur, and that also take a part in increasing and enhancing the creep. So what we can do, we can use the material which are having only single crystal material, and their uh, uh, you know grain size must be large, not fine. Okay, so coating and surface treatment. Apply the thermal barrier coating, TBC. So what we do, we have options. If we have the material and that we don't have a supplement of that, then what we can do the coating of the material with coating material. We can use the coating material and we can coat the parent material uh, with the material which are having the high temperature. So coating material would be having high temperature resistance, and the core material and the parent material is not basically having capacity to resist the temperature at a high temperature, or resistance to temperature. So what we can do, we just take a coating of the material which are having a high temperature resistance, so that because the area which is outer side where we can do the coating, and that is going to take the participant in application part to the they would be exposed to the temperatures. Okay, so that coating will help reducing the creep, right? Design optimizations. So what are the design? So reduce the stress concentrations using the smooth geometries. So how the design optimization going to reduce your creep nature, because the design parts basically decides what are the stress concentrations area that you have left inside the design. Suppose you have the notch design, it means the notch will having the high concentration areas. Okay, and if they are having the high concentration stress, it means they will lead to the creep, right? So how we can reduce the stress for the same loading? We are not increasing the load for the same loading. If you have the design is very rough, or you can say your design is having the notches, Okay, then it must get fail very earlier for the same loading. For that, what we can do, we could do the design which are having a smooth design. They are not having any kind of the notches. They or in other way, you can say the design must not containing any stress concentrations areas. Okay, so that for the same load, you must be having a sufficient stress. Sorry, you would not be getting sufficient stress for the creeping. Okay, so you are under that category of stress if you have made your design very smooth and there is a and they are stress concentration free. Okay, so that depends over the design. Okay, so our design must be in that way. Okay, now, the cooling systems use the active cooling to lower the material temperatures. So, what other methods that we could do? The other methods are we can use the cooling, okay, so that we can reduce the temperatures. I mean, the part that has been exposed to the high temperature, if it is possible. Though all the times we don't have that facility, we cannot go with the cooling or providing the coolant, okay, because sometimes we don't have that options, okay, but most of the time that we are having options, so we can provide the coolant, okay, so that the temperature comes to down little bit and we can resist the creeping natures or creeping. Okay, so this all about this was all about creeping. A creep failure is a note. In short, what is a creep? The creep is the critical factors in a high temperature applications. By understanding its stages, mechanism, failure modes, and preventing techniques, engineers can design materials and structures that withstand long-term exposure to the high temperature and stresses. Okay. Advanced materials like the superalloys, ceramics, and composites are continuously developed to enhance the creep resistance. So these all are just, you know, the method or the R&D is being done so that we can enhance the material properties for application of creep. Okay, and what the property that we can do? We can enhance the material properties in the way of what? In the way of increasing the temperature resistance, and they can have a good design so that they are stress concentration free designs. Okay, this was all about for your creep.